Assalamu alaikum, dear students. Today we can move to another topic, variation of g acceleration due to gravity with the shape of the earth. In previous classes, we have discussed acceleration due to gravity and variation of acceleration due to gravity with the altitude of the earth and with the depth when we move from the surface of earth towards the center, how acceleration due to gravity changes. You have seen it that acceleration due to gravity becomes zero at the center of the earth. Now we will try to, today's topic is, it is also in our syllabus, variation of acceleration due to gravity with the shape of the earth. As we know that earth is not a perfect sphere. It is not a perfect sphere. It is just like an oval shaped, just like an egg shaped. That means if we draw the actual picture of the earth, it resembles the shape of just like this. You know this. This is called poles. If you remember, poles. These are called equator. This is the equator line, a line which bisects the earth into two equal parts. That's equator, and these are called polar. These and these ends are called poles of the earth. That means, suppose this is the center of the earth. This is called the radius of the equator. A. It is called the radius of the pole. We have seen that earth is not a perfect sphere. It is flattened at the poles and bulges out at the equator. That means earth is not perfect sphere. Okay, it is flattened at the poles and bulges out at equator. Okay, so the equator radius of the earth is greater than the polar radius. This equator radius is greater than the polar radius by about, that means radius of equator is greater than the radius of polar radius. That means equator radius is greater than the polar radius. Almost, it has been found that equator radius is almost 21 kilometer greater than the polar radius. That means it is radius is 21 kilometer greater than the polar radius. That means equator radius is almost 21 kilometer greater than the polar radius. But we have seen the relation of acceleration due to gravity. Acceleration due to gravity on the earth's surface is given by, if you remember the equation, g is equal to gm divided by r square here, where g is the universal gravitational constant, m is the mass of the earth, r is the radius of the earth. That means we know that here g and m are constant. Universal gravity, g and m are constant. M are constants. That means they are constants. That means here g is inversely proportional to square of radius. This is inverse square law also called inverse square law. That means value of g is inversely proportional to square of the radius. That means where radius is much, acceleration due to gravity is less. Where acceleration due to gravity is large, radius is less. That means from this equation we can calculate that, we know that as radius of equator is greater than the radius of polar radius, that means equator radius is greater than the polar radius. Why? Because it is almost 21 kilometers. Because the shape of earth is not in sphere, it is flattened at the poles and bulges out at the equator. Okay, I hope you have got it. That means from this we can say, that means acceleration due to gravity at equator is less than acceleration due to gravity than polar. Since this radius is greater than, they have an inverse relation. That means acceleration due to gravity at equator is less than the acceleration due to gravity at polar. That means the shape of earth also affects the acceleration due to gravity, because from this relation we can simply say that it is inversely proportional to square of the radius. That means we know that equator radius is almost greater, it is greater than the polar radius. Almost how much it is greater than? It is 21 kilometer greater than. That means thus the value of g is minimum at the equator and maximum at the poles. That means value of g is minimum at the equator and maximum at the poles. That means here it is minimum when it goes from rotation. When it rotates here, it becomes minimum. Here it becomes maximum. When it comes, it goes on decreasing, and again goes on increasing. And when it reaches here, it becomes the maximum value. That is why the weight of body increases. That means acceleration due to gravity. You know that we know that weight is equal to force. That is called mg, mass into acceleration due to gravity. That is why the weight of body increases when it is taken from equator to the poles. That means अगर हम वेट यहाँ कर लेंगे, अपना वेट यहाँ कम हो जाएगा और यहाँ ज़्यादा हो जाएगा, बिकॉज वैल्यू ऑफ जी और इंक्रीज. द वेरिएशन ऑफ जी बिटवीन द पोल्स एंड इक्वेटर इज अबाउट 0. इट हैज़ बीन फाउंड इज 0.5%. इट इज़ द वेरिएशन ऑफ एक्सेलरेशन ड्यू टू ग्रेविटी बिटवीन द equator and the poles. I hope you have got it. That means shape of the earth also affects the acceleration due to gravity. This is all about the acceleration due to gravity. Thank you very much.